Now let's talk a little bit about H2SO4, because H2SO4 is kind of a special polyprotic acid. Because in the first equilibrium, this first equilibrium right here, okay, is a strong acid, okay? So H2SO4, its first proton, its first H that it loses, is a strong H, so it completely ionizes. The second H is a weak acid, okay? But it is an extremely strong weak acid. That Ka is about as high as we've seen in this chapter. So in other words, when we're thinking about H2SO4, it loses, more than one proton on average, okay? So we're going to have to think about this a little differently, and we will do an example on this. Now, the thing to remember is because the first ionization is complete, it is a strong acid, then we don't really have to do a first equilibrium to solve for the second equilibrium, because we know whatever the concentration of H2SO4 is, that is the same concentration of the HSO4 and the H3O plus that will come out from the first equilibrium, which isn't really an equilibrium. So let's talk a little bit about H2SO4. What is the pH of a 0.01 molar sulfuric acid solution? Well, the first equilibrium is for a strong acid. So we generate 0.01 molar H3O plus from that. And we also generate 0.01 molar of the conjugate acid, which is a bisulfate ion right here, okay? Now we use that answer from the first part to get to the second part. So what we do is we plug in, we have 0.01 molar HSO4 from that first dissociation and 0.01 molar H3O plus, and it is approximate because we still haven't come up with our final answer yet, if you will. And so what we'll say is, because our second Ka is so large, okay, if you see anything this big for a Ka, you can pretty much assume that X is not going to be negligible. So because it's so large, we have to do the full scale. Okay, we got to set up the Ka2 and have plus X and minus X, and we can't cancel these X's out. So now we have to do a little algebra and get to our quadratic equation, which you can see solve for right here. Okay, then we know that X, okay, right here is 0.0045. Okay, and so we know the total concentration of H3O plus is the 0.01 molar from the strong acid plus X from this weak acid's dissociation. And so when we add both of those together, we get a total concentration of 0.0145 and thus a pH of 1.84. So H2SO4 is an incredibly strong acid because it's almost more powerful than strong acids like HCl or HNO3, nitric or hydrochloric acid, because you get more than one proton on average from a solution. This concentration of H3O plus is higher than the concentration of the H2SO4. So that makes it a very strong acid, and you don't want to mess with H2SO4, let me tell you. Plus, just pro tip, don't ever sniff a solution of strong H2SO4. You will smell sulfur for a week. Personal experience.